Today we're going to be talking about scientific notation. So the definition of scientific notation is a number expressed in scientific notation is when it is written as the product of a number between 1 and 10 and a power of 10. Remember, the word product is the word for the answer to a multiplication problem, so product is just going to remind us that we're multiplying. The number that we talked about here between 1 and 10 must be greater than or equal to 1 and less than 10. So it has to be at least 1 or a little bit higher and no more than like 9.99999, so right under 10. Examples of scientific notation could be 3.2 times 10 to the first power, or we could have 6.7 times 10 to the negative 7th power. So notice we have that number at the beginning, like here we have 3.2. That's greater than or equal to 1 and less than 10. We're multiplying times a power of 10, and in this case it was a positive power of 10. We could also have the 6.7, it's between 1 and 10, and we're multiplying it by a power of 10. This time it was a negative power of 10. So both of those are good examples. Non-examples would be something like 55 times 10 to the 7th. So we have this number here in the front, but it's greater than 10. It's not between 1 and 10. So this 55 here would be too big of a number, but the rest of it, even though that looks okay, it's that 55 that tells us this is not good. It's greater than 10, so that wouldn't work. Standard form to scientific notation. Standard form is just how we're used to seeing numbers, and we're going to learn how to write them in scientific notation. So the first step is when you're reading a number from left to right, just as we normally would, place the decimal after the first non-zero digit of the number. So we have an example using 3,400. So when we're reading this number from left to right, the first non-zero digit that we get to is 3. So if we're going to put the decimal right after that, we would place it right after the 3. So the decimal that we're making becomes 3 point, and then we write the rest of that number, 3.4. But if we have 3.400, we don't need to include those zeros. They're just kind of placeholders, and since they're the only numbers at the end there, we don't need to include them. So we put our decimal after the first non-zero digit, and we made 3.4. That is between 1 and 10, so that would work for our number between 1 and 10. Once we've figured out, okay, we're going to make 3.4, we have to think about how far were we moving our decimal to make 3.4. So if we're using the same example, 3,400, if I have $3,400, my decimal point is going to be right here at the end, and you could imagine that we have these zeros at the end of it. That kind of looks like money, so that's how I remember where to put the decimal. It always starts right at the end there, and we moved it to make 3.4, so it landed here. We need to count our loops, 1, 2, 3. It took us 3 spaces to move our decimal, to get it from where it started at the end of 3,400 to make 3.4. So in step 3, we're going to just combine everything we've done. This says the number that we made greater than or equal to 1 and less than 10. So remember, we made 3.4. We multiply that by a power of 10, so we put 10 as our base here, and our exponent that we need to use is the number of spaces that we moved. In this case, we had moved 3 spaces. So we can say that 3,400 written in scientific notation is 3.4 times 10 to the third power. So in these next few problems, the question says, where would you place the decimal to write each number in scientific notation? How many places did the decimal move? So looking at 4,500, remember you read from left to right and you put the decimal after our first non-zero digit. The first non-zero digit here is 4, so we're going to make 4.5. And remember, we don't need to include the zeros at the end there because they're all at the end of our number and they don't mean anything, so we can just drop them. If our decimal starts here, $4,500, remember our decimal is always at the end of our number here. And to move it to make 4.5, we'd be moving it 3 spaces. So we can write 3 spaces. Go ahead and pause the video and try the other 3 just like this on your own. Okay, hopefully you took a minute to try those on your own. In this next example, we have 8,600,000. The first non-zero digit here would be 8, so we're going to put our decimal right after the 8, so we make 8.6. Again, all those zeros at the end, we don't need them. They're not being held in by any other number. To make 8.6, our decimal would go here. In 8,600,000, it would have started here. That's going to mean we had to move it 6 spaces. In our next example, we had 5,555. Our first non-zero digit when we read left to right is this 5. So we're going to make 5.555. Now notice I have 3 numbers after my decimal point here. That's because we didn't have any zeros at the end of this number. So there's nothing that we can get rid of this time. We are going to write 5.555. And our decimal would have started at the end here. That's going to mean it needed to move 3 spaces. In our last example, when we read from left to right, our decimal would end up behind the 7, so we made 7.8. In 780, it would have started here. That means we're just moving it 2 spaces. So now we're going to use the skills that we just learned to write each of these numbers in scientific notation. So our first step is to figure out where we're going to move our decimal. So in 125, remember our decimal is going to start right at the end here. And we're going to move it to right behind our first non-zero digit. So when we read left to right, the first one is right here, right after that 1. So the number that I made between 1 and 10 is 1.25. I need to write times 10. And then we're going to see we had to move 2 spaces, so that means the exponent on our 10 is 2. So 1.25 times 10 to the second would be how we write 125 in scientific notation. Go ahead, pause the video, try the rest of these on your own. Okay, hopefully you've taken a minute to pause and try these before you're checking them with our work. So our next example was 78. When we first read this from left to right, our first non-zero digit is 7. So we're making 7.8. And 78, the decimal would have started here. That means we're only having to move our decimal 1 place this time. So we're going to write times 10 to the first power. In our next example, we have 5,800,000. Our decimal would start here at the end. To make a number between 1 and 10, we look from left to right. Our first non-zero digit is 5. That means we made 5.8, and we can drop all those zeros because there's no other number holding them in at the end here. We're moving our decimal 6 spaces this time, so we're multiplying by 10 to the 6th power. In the next one, we have 31,400. The decimal starts at the end. To find our number between 1 and 10, look from left to right. The first non-zero digit is 3. So the number we make is 3.14. We have to move our decimal 4 spaces here. So we multiply by 10 to the 4th power. Next example, we have 4,300. The decimal starts at the end of the number here. Reading from left to right, our first non-zero digit is 4, so we make 4.3. And we need to move our decimal 3 spaces, so we're multiplying by 10 to the 3rd power. In this final example, we have 2,600. Our decimal would start at the end of this number. Reading from left to right, our first non-zero digit is 2, so we make 2.6. We need to move our decimal 3 spaces this time, so we're multiplying again by 10 to the 3rd power.